I am on page 117 of the exercise book, and I have just copied these two problems out into the notebook. Now, this is something I've drawn. I actually recorded this video before, and when I went to upload these to Schoology, it was gone. So I came back. I'm going to have to record it again, and I didn't want to draw this graph again. So I'll tell you about that in just a second. But first, let's read this story. Again, this is page 117 in the exercise book. Mr. Bott hits his golf ball off an elevated tee 64 feet from the ground. The height of his golf ball after T seconds is... Mrs. Bott hits her golf ball off an elevated tee, and the height of her golf ball after T seconds is represented by the graph to the right. Which statement correctly describes the flight of Mr. Bott's and Mrs. Bott's golf balls? So the first thing I'm going to do is study this graph. This is the graph of Mrs. Bott's golf ball. And I'm going to come in here and plot some points for you. There's a point. There's a point. There's a point. And here's a point. This point is also known as the relative or the maximum here. So this is the highest point that Mrs. Bott's golf ball reached. So I'm going to come over here and set up a table of values for Mrs. Bott's, because I can tell by looking at this graph what these points are going to be. Mr. Bott, we're going to have to work for. But let's take a look here at what we have. X is going to be the seconds. That's the independent variable. And Y is going to be the height in feet. So X is the seconds and Y is the height in feet. So at 0 seconds, Mrs. Bott's golf ball was at 48 feet. That was its starting point. And just for review, that is the y-intercept. When x is 0, y is 48. So no seconds have passed. Her golf ball is at 48 feet. When 1 second has passed, her golf ball is at 64 feet. When 2 seconds have passed, her golf ball is back down to 48, so it's reached the maximum and it's starting its descent. And then at 3 seconds, it intercepts the x-axis, so that is the x-intercept, which tells me that at 3 seconds, it hits the ground because it's in the air for 3 seconds and touches the ground at the 3-second mark. So just by looking at this graph and those 4 points, I can build the table of values. Now, I want to do the same for Mr. Bott. So I'm going to bring this table of values down. Let me try that again. Nope, it's going to take everything. Bear with me. I don't want to pull everything. I just want to pull this table of values. So I'm going to copy that. And I'm going to bring it down here to this question and paste it right here. Now remember, this is Mrs. Bott. We don't want to get them confused. So I'm going to make a different color for Mr. Bott, just to help my brain not get them confused. So I'm going to build a table of values for him as well. Now we know the y-intercept because the problem told us that he hits the golf ball off an elevated tee 64 feet from the ground. So when no seconds have passed, Mr. Bott is already higher on the tee than Mrs. Bott. Now, I will confess to you that I do not understand that at all. I do not golf. I don't understand why you would hit a ball from 64 feet in the air, but if you are a golfer, you could explain that to me. But I don't need to understand that to do this graph. So I'm going to use the same values. That's important because we're comparing two graphs. And I want to figure out what is happening to Mr. Bott's golf ball at this time. So I need to go back and get that equation right here. This is the equation that I want to use. So I'm going to write this down. Let's come down here where I have some room to work. And the equation is the height at t seconds is negative 16 t squared plus 120 t plus 64. So the first value I'm going to put in is 1. So when Mr. Bott's golf ball is 1 second into the air, let's go ahead and substitute. I'm not going to write the equation again, the generic form. We'll put the value in. So negative 16 times 1 squared plus 120 times 1 plus 64. So this is going to be negative 16 times 1 plus 120 times 1 plus 64. So we have negative 16 plus 120 plus 64. And I'm not even going to risk it. I'm going to go ahead and type this into my calculator just the way it's written. And I end up with positive 168. So the height at 1 second is 168 feet. So let's do that on the table of values. Then I will test this again using the 2. So the height of the golf ball at 2 seconds is negative 16 times 2 squared plus 120 times 2 plus 64. And the 64 is significant because that was the starting point. Remember, he was on an elevated tee. So negative 16 times 4 plus 240 plus 64. This is going to be negative 64 plus 240 plus 64. So the 64s cancel each other, and I'm left with 240. So the height at 2 seconds is 240 feet. And let's put that in here. And then one more, let's do the height at 3 seconds. So negative 16 times 3 squared plus 120 times 3 plus 64 is going to be negative 16 times 9 plus 360 plus 64. 16 times 9 is 144. It's negative. That's important. Don't lose that negative sign or you're going to be sending that golf ball way higher than it needs to go. So negative 144 plus 360 plus 64 is 280 feet. Okay. So let's graph Mr. Bott's progress. So at 0.64, you can see where I plotted that one already. We have his starting point. Then at 1.168, So about right here. These are just approximations on this graph. Otherwise, the graph would be enormous. Then at 2 seconds, we have a height of 240 feet. That one is right on an intersection. And then at 3 seconds, we have a height of 280 feet. So even at 3 seconds, the ball is still climbing. But it looks like that is going to be the maximum. We will need to find out for sure. We can't just hope that or assume that. But I think it is. And the way that I can tell is that if you look at this distance right there and then this distance, they're getting shorter and shorter. So if that's not a maximum, it's very close. But to know for sure if that is the maximum, I'm going to have to go one more second. So I'm going to say h at 4 seconds is negative 16 times 4 squared plus 120 times 4 plus 64. So we have negative 16 times 16 plus 480 plus 64. So 16 times 16 is 256. That is negative. And I do believe that was our maximum. But let's see. We can't just assume that. No, it was not our maximum. Because here, the height is 288 feet. I really thought it was the maximum. But that's what I get for assuming. Because this one is going to have to keep going up to 288. So 1, 2, 3, 4, it would be somewhere about here, and surely that's the maximum, because you see that it's starting to make that curve. But let's check. Let's go ahead and do 5. I really want to know when that ball starts to turn. All right, so I'm going to plug in h of 5, the height at 5 seconds is going to be negative 16 times 5 squared plus 120 times 5 plus 64. So we have negative 16 times 25 plus 600 plus 64. So 16 times 25 is 400, and that's negative. And it has made the turn. We have 400 negative plus 600 plus 64. It is only at 264 feet at this point. So at 5 seconds, it will have made the turn. It's going to be about right here, maybe. But the point is, it has reached the maximum, which would be here. And it is starting back down. Now remember, this is at 5 seconds, so it's in the air still. But it is starting to descend at this point. And that's going to help us in the next problem. Okay? But here's back to the question. Mizra's golf ball stayed in the air longer. That's false. Because remember, Mizra's golf ball hit the ground at 3 seconds. Mr. Bott's golf ball hadn't even reached its maximum at 3 seconds. Mizra's golf ball travels higher than Mr. Bott's. So this is saying that what was her maximum? 64. Sorry. what am I trying to do here? Okay. This is saying that 64 is greater than 288. And that is a false statement. You compare the maximums for that one. Mrs. Bott's golf ball travels farther than Mr. Bott's golf ball? No. Mr. Bott's travels higher and it's in the air longer. So the opposite would be true there. Mr. Bott's golf ball reaches a greater maximum height than Mrs. Bott's golf ball. That is true. 288. True statement. Mrs. Bott's golf ball stays in the air for 8 seconds. That is a false statement. It only stays for 3 seconds. Now, if I were on a test and I were running out of time and I had to pick the true statement here, I would use common sense. Mr. Bott is hitting the golf ball from a higher starting point than Mrs. Bott. Also, and this is maybe not the best logic in the world, but you could almost guess that Mr. Bott could hit the ball harder given that he's a man. Generally speaking, males are going to have more, I'm not going to say they're better golfers, but they're going to be able to hit the ball with more force in general. Sometimes that's not true. I know women who could hit the ball equally to men. But again, if I'm on a test and I'm having to make a guess, I would assume that. You could almost answer number 12 with just good old-fashioned common sense. The fact that Mr. Bott is higher up, he's almost 20 feet higher when he hits the ball, would make me think that his ball is going to go higher than Mrs. Bott's. So the answer to number 12 is D. Number 13. I was hoping that we would not have to answer this, but we do. After how many seconds will Mr. Bott's golf ball hit the ground? Well, I can eliminate A and B by looking at this graph or this table of values. A is a negative time, and unless you're launching a space shuttle, you don't usually worry about negative time. B is not true because I can see it. At 3 seconds, the ball hasn't even reached maximum. So I'm going to eliminate that one. I can eliminate D and E because at 5 seconds, that ball has already started to fall. So I know the answer has to be A, given the choices I have. But I need to show you why it's A. And to do that, we're going to need the quadratic formula. So I'm going to come down here and set up the quadratic formula, which means we're going to need to know A, B, and C. And I'm going to have to look up the quadratic formula. I should know it, but I don't use it enough to know what it is. Negative 16t squared, 120t, and 64. So this is the position function that we're going to use. Negative 16t squared plus 120t plus 64. So the values are going to be A is negative 16, B is 120, and C is 64. So those values I can pull directly from the position function. And that, remember, is h of t. Okay, now I need the quadratic formula. So give me just a second to look that up. It's not the letters that I forget, it's the signs. And I don't use this enough to keep it in my mind. I promise you it's not something I think about all the time. So it's on page 134 of your textbook. That's in another chapter. But again, I just need that formula. I'm going there. You can fast forward through this video if you don't want to go there with me. All right, here we go. The quadratic formula is x equals negative b plus or minus the square root of b squared. That's my problem. I always want to make that b negative. 4ac, and then I know that on the bottom is 2a. All right, so we need to substitute. Let me check this again. Yes, we need to substitute our values and figure out what our formula is going to say. So x equals negative b plus or minus the square root of b squared minus 4ac, and that is all over 2a. So just substitute very carefully. This is where I make my mistakes usually, is in not substituting correctly. Negative 16, 64, 2, and negative 16. Okay, so let's solve this thing. We have negative 120 plus or minus the square root of 120 squared um, 4 times 16 times 64, and that is positive 6144, all over negative 32. So then I have negative 120 plus or minus the square root of, yikes, I hope that's going to be even when we do the square root. So x equals negative 120 plus or minus, not square root, I'm going to say about 143. We'll just call it 143. It's not going to be exact because I'm rounding. And over negative 32. Okay, so here we go. This is where it splits off into two different formulas. So I'm going to work it this time using the plus sign. So we have negative 120 plus 143 divided by negative 32. So 143 plus negative 120 is 23. That's positive 23 over negative 32. So that's going to be the value of x when you use a plus sign. Then on this side, I'm going to use the value of x when it's negative. So x equals negative 120 minus 143 all over negative 32. So x equals negative 263 over negative 32. And that is approximately 8.2. Well, it's not approximately. Let's do it. So about 8 seconds. That's the answer I'm looking for. Time can't be negative in this situation, so you wouldn't want a negative number. So I'm going to go with about 8 seconds, which is consistent with my graph. It's also consistent with my problem. And see, I knew that before I even did that quadratic formula. So if you can figure it out without doing the formula, that's great. Do that, because that will help you save all this time. That was a lot of work. You can imagine how frustrated I was when I realized that video didn't save the first time. Okay, let's check it, and then we will move on, assuming that it's okay. This is page 117, and number 12 is D as in dog, and 13 is C as in cat. So we are good to go on those. What a nightmare. I will see you in the next video, and we'll tackle numbers 14 and 15.